Here on page 2 of 7.3, we've got just some more examples. We'll keep working through them until you feel comfortable and can take off on your own on the problem sets. The instructions are the same: factor each trinomial or state that it's prime. Prime would happen again if you would, once you get your A and C multiplied together and you start listing factor pairs and you can't find any that will equal B either when added together or subtracted, depending on what your sign is here. You can't find a pair that works, then it's prime. Now if you pull out a GCF, you still have that as a factor, so it is factorable if there's a GCF. But if there's no GCF and no pair, then the whole thing is prime. And of course you can multiply to check. So let's try. We've got 9y squared plus 5y minus 4. What's different about this one? Well, you've got y's involved. You discovered that's really nothing different. We have a subtraction here, positive here. That means we're going to be subtracting. That really isn't anything different than we've done. Not too much really is noticeably different. So I think we're just going to be able to follow same steps as before. Well, not I think. I know we will, because that's the way we've set it up. Follow these steps, it works every time. So we're going to be boringly good here. We ask ourselves right away, is there a GCF that factor that all three terms have in common? And no, there's not. You'll notice that's the case for a lot of these, but we want to build the habit so that when we do run into one, we're just automatically checking for it. So that's our first question. Our second question is, how many terms are we looking at? And again, pretty boring at this point because everything in this section is the same. It won't be till we mix them up that we'll be able to see how these two boringly good steps come into play. Because the answer is always going to be 3 in this section, which means that our plan is to convert it to 4 terms so that we can factor by grouping. The way we do that is we do a strategic split here. So we look at our A, B, and C values, where you have ax squared plus bx plus c as our standard form. And that means in this case A equals 9, B equals positive 5, C equals 4, and we're going to make note that that 4 is negative. So it's a minus in front, which means we're going to subtract to get our B value. So we start with our A times C, which is going to be 9 times 4, and that gives you 36, and we're going to split that into factor pairs: 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And I was just listing them, but if you can kind of keep track as you go, we were looking for subtraction that gives you 5. The pair that you would be able to subtract to give you 5 would be 9 minus 4 would equal 5, which means that's the way we're going to split the 5. We're going to make it 9y minus 4y, and that's going to equal our 5y. So that's how we're going to split it, 9y minus 4y. And again, it doesn't matter which order. We could have done negative 4y plus 9y. We could have done it that order too. As long as the negative stays with the 4, you still get a positive 5y. You would just reverse that and keep the negative with the 4. But as it stands now, we'll keep the plus 9y, and then we'll bring down our 9y squared plus 9y minus 4y, bring down the minus 4. And then we're going to factor by grouping. So we look at what the first two have in common. We've converted now to 4 terms, so now we factor by grouping. So the first two have a 9 and a y in common, leaving behind a y plus 1. If we divide out or undistribute that 9y, what's left is the y plus 1. We can expect to see a match here of y plus 1. So we look at the second two terms. What do they have in common? Well, they have a 4. In fact, they have a negative 4, and the reason why we're clued into taking a negative is because that leading sign is negative. If you forget and just pull a regular 4, let's try that here just to see what that would look like. It would leave behind a negative y minus 1. Negative y, which is close to what we want, but not an exact match. It's not exact, but it is close. And then we remember, oh yes, I should have pulled a negative. So let's try this again here. We pull the 9y, y plus 1, and this time we pull a negative 4, leaving behind a y plus 1. If we were to redistribute the negative 4, you get negative 4y minus 4. And now we have our match. And now we can pull that as our big GCF here. Our y plus 1, leaving behind the 9y minus 4. And we could distribute that to, or refoil it, or just double distribution to check that that would be what we have in the original. So this is the factored form of that. And looking at number 56, what's different about this one? Well, we have an a value, which shouldn't be a surprise by now, that's not really different, but we do have an a squared and then a b squared and then an ab. We've done this before in 7.2. It's going to be the same deal. Instead of just having, splitting the a's, we're going to split the b's as well. With our method of strategic split and doing the 3 terms to 4 and factoring by grouping, that'll all happen naturally. We don't even have to worry about it. The other thing we might notice is we're trying to get a negative value, and we're going to be subtracting to do that. So again, we've been practicing paying attention to the signs, so it really doesn't cause that much of an issue to have all these different things going on. So we start, of course, by seeing, is there a GCF all the way through all 3? And there's nothing that all 3 terms have in common, so no GCF here. Second thing, how many terms? In this case, of course, we've got 3, being very boringly good here. It's going to be all the same when we're in the same section. Once things mix up, though, and you've got all kinds of different problems to choose from, which will happen in the sections coming up, as well as on the exam, then these 2 starting questions, GCF, how many terms, become critical to your success. But because there's 3, we're going to use our strategy to convert to 4 terms. And here's how we'll start doing that. We've got our standard form of ax squared plus bx plus c. Don't get too confused by the fact that there's another variable here. The a is going to be that number in front of the squared term. So our a value is 3. Our b value is going to be a negative 1. And we do keep the sign of that b value. We would need it to equal negative 1. Our c value is going to be just the number 14, but we make a note that it is negative, which means we're going to subtract. And let's go ahead and get our AC multiplied together. A times C, which is going to be 3 times 14, that's equal to 42. And now we're going to strategically, we're going to split that into factor pairs. Pardon me. We're going to split that into what multiplies to get 42, looking for a pair that when we subtract it will give us a negative 1. So 1 and 42, 2 and 21, 3 and, what is that, 14? 4 doesn't go into it, 5, but 6 and 7, and there's our pairs. Now we're looking for a pair that when we subtract it, it will give us a negative 1, and right here 6 minus 7 will give us that negative 1. And very important that that order is maintained in terms of which has the minus in front of it. 7 minus 6 does not give you negative 1, it gives you positive 1. So it's got to be the 6 minus 7. So it's going to be 6ab minus 7ab is equal to your negative 1ab. Or you could do it as negative 7ab plus 6ab is equal to your negative ab. It really doesn't matter which order. Some of you, as you start to get real comfortable with this process, you might look ahead because the way you place them we can help you with your factoring by grouping. It might make it easier, but really it'll work either way. It really does not matter. So we're going to go ahead and split this. I'll go ahead and just do the 6ab minus the 7ab, and without the sign, that 6 is positive. And then we bring down our original terms to go with it, 3a squared, let's see if I can give myself some space here, and the minus 14b 2b squared. Sorry, it's a little cramped. And we've now successfully converted to 4 terms, so now we're going to factor by grouping. What do the first two have in common? They have a 3 and an a, so that's what we'll pull out, leaving behind an a plus 2b. Redistribute to check. 3a times a is 3a squared, 3a times 2b is 6ab. And now we can expect to see the a plus 2b show up again. So we look to see what the two pieces have in common, negative 7ab and negative 14b squared. And the negative in front of that first term gives us that tip-off. We should pull a negative. If we don't, they'll be really close. There'll just be a difference of signs here in terms of the matching piece. And then that we realize, oh yeah, I'm supposed to pull a negative. So let's go ahead and take the tip off here and pull a negative 7. And that would, oh, and also they have a b in common. Sorry about that. Negative 7b. Can I squeeze it in? Oh, close one. Negative 7b, leaving behind an a plus 2b. Negative 7b times a is negative 7ab. Negative 7b times 2b is a negative 14b squared. And there it is, the exact match. So that's the big GCF, that's the match. Big GCF that we're going to pull out here, a plus 2b, leaving behind 3a minus 7b. 3a minus the 7b, that's where we got that. And there it is in factored form, and you can always check that by refoiling it out.